Hey, hello champions, welcome to this session. So in last videos, I think you might have created the load balancer, the application load balancer, but now let's indicate or create a failure. Now, why we are creating this failure? The reason we are creating this failure is to show you why we created load balancer. Okay, so the load balancer would detect the failure by itself. So now there are two types of failure that we can create. One is the application failure, the second is system failure. To generate the application failure, what I'll do is I'll log into Putty. So let's bring in Putty software quickly. And again, to make sure that you are able to log into the resources, you remember you are doing a SSH. So make sure you are opening SSH for your IP. So I'll say my IP, or to show you the clear way, say add rule, click here SSH, because we want to take a remote of this session. And I'll say SSH allow only for my IP, okay? Because the audience should not be able to do SSH. So I have allowed SSH for the security group for all these instances. Now let's come back to the load balancer instances, or let's open the third tab of instances. So what I'll do is I'll go on the load balancer and I'll introduce a system app failure. So let's try connecting on the server A. So remember how to connect that in the session. I'll copy the public IP. I'll use the private key here. If you're not sure about this, I want you to refer to our video on EC2 and check out how to create a instance, EC2 instance, Linux instance, and connect to that instance. Okay, that will show you this precise steps. So you can see I am able to log in. EC2-user is the username, and I am on this server A. Okay. Now I'll create a system failure here. So imagine there is an application running like Facebook or whatsoever your customized application. So Apache is running. Okay, so you can see to check if Apache is running, you can run this command HTTP. Sorry. Okay, you can see Apache is running, or the other command is service HTTPD status. So you can see the Apache is running. Now imagine the application is hung, or the application there is a problem here. So you can see application is running. Now what I'll do is I'll introduce a application failure, which means I'll stop the application. So service HTTPD stop. Okay. Now watch this. I'm going to stop the application on server A. Okay. So I'll say stop, and you can see the status. It is stopped here right now. And if I check the load balancer, let's hit that again. You can see I got 502 bad gateway, which means the request went to A server. One more request, 3 requests, 4 requests, 5. Okay, it seems like this is cached. Okay, now it is done. So in terms of seconds, if you count it, it took 9 seconds, 6 to 9 seconds, less than 10 seconds for it to identify that the application is down, which means the server is unhealthy. And now you see the request is no more going to server A. It's going to B, C, B, and C. It will not go to A. So yes, definitely you are able to see error few times. But do you see, if you talk about the real production scenario, again, this can be minimized. You could see 3 or 4 failures requests, but if you see in terms of seconds, it was hardly 6 to 9 seconds. I was continuously refreshing it. Now imagine when your system engineer is working with this kind of load balancer thing in place, you see there is a system failure, but you still have some time because there are other servers in place. So you can say BC are still working. So maybe some users got access denied or the bad gateway only for limited time until your load balancer is able to detect the failure. But once detected, the load balancer is not sending any more requests to that instance. It's sending only to B, C, B, C. It's not sending to A. And let me prove that to you. So here you can see the server A. Now if I refresh this, server is no more working, right? Because we stopped the application. So this will keep whirling and it is timed out. Now let me show you the interesting thing. So let's go back to target group, and you can see it has found 1 instance is unhealthy and 2 are healthy. So you see, just because it is unhealthy, and you can see the server A is unhealthy, this is the purpose of an application load balancer. So when you are having multiple instances, if there is an application failure, load balancer is smart enough to identify that and no more request sent to that application load balancer. Okay, so this is the application failure. So you can see right now, this is unhealthy, too healthy, and that's why the request is being sent only to B and C. Maybe 6 to 9 seconds. Okay. Now let's bring that application once again so that I prove it to you that, okay, how does it ensure that let's assume that, you got a message alert, monitoring alert. So you figured out the problem and the service is up and running now. Okay. So service HTTP start and status. So you can see the service is running right now. If I show you, if I refresh this page quickly, you can see the server A has come up. And now if I go back to load balancer, it might take a little time to identify that A has come up. Because you remember, it needs to have 3 healthy checks. Every 3 seconds, every 15 seconds, it would give a check. 3 healthy checks, which means it is healthy. 2 unsuccessful checks, which means it is unhealthy. So it will need 3 checks, success checks. Now you see the request is again going back to A, which means the load balancer figured out that the A is again working and it already is now serving the request. Okay. So if I come back to the target group and if I, without any refreshing the screen, you can see 0 unhealthy, 3 healthy. This is the smart way. This is the purpose of a load balancer. Okay. So if I scroll down, you can see every server is healthy. And this was a demonstration of a the application failure. Okay. So in the next video, I'll show you a system failure. But here I wanted to do a quick demo of application failure, and I'll see you in the next video. Cheers. Bye-bye.